just wanted to show you a new motor generator. This is the MG-2, and you've probably heard the MG-1 is on hold at the minute. Basically I was fighting with it a bit too much to try and get it to work the way I wanted to, and I just saw lots of things about it that I could have improved if I built it again, so I did. And now it only has one rotor, which you can see there, and still two sets of coils on either side. I'll show you the dimensions for all those in a bit. The magnets are triple stacked neodymiums, or however you pronounce it, neodymium, the Americans. And yeah, three sets of coils on either side with the Brooks coils configuration. At the minute I just have it running off standard Bedini circuits, but I am going to change that because I want to pulse the coils in a certain way. It's not doing too bad. At the minute it's measuring about 35% output compared to its input, and goes about 1,500 RPM, but it's constantly under load because all 6 of these coils have, well, they're bifilers, and one winding from each of the coils is used as the primary power windings, and they're all in series. As I say, they're bifilers, so the secondary windings on each of these coils are wired in series, and that basically lets the coils act as combined stator and generator coils, and that just makes the unit nice and compact. Has a few other effects which I won't go into at the minute, but may do later. So anyway, I'll plug it in and just see it whiz up. Okay, I've got the batteries hooked up to it. I could technically run it off just one battery and just loop it back because of the recovery coils, but I'm not going to do that at the minute. I have the oscilloscope hooked up to the charging battery because unfortunately I can't stick it on the transistor or the coils because it's all enclosed, but I might put some leads on the outside of the casing, so that's a bit easier to do in future. But you can sort of see what's going on by looking at the charging battery terminals. So yeah, let's just whiz it up. There you go. Well, it doesn't take long to get to top speed. It's only 1,500 RPM, about 75 Hertz. As I said, that's the rotor spinning there. Very small clearance from the coils. And also because of the shape of it, it's got very low wind resistance. Like you saw before on the MG-1, if I was to stop the motor, well, cut the power off to the motor, it would freewheel for about 2 minutes. On this thing, it's just ridiculously long. I won't even be able to fit it on the YouTube video. It just keeps spinning by itself. Not saying that's free energy, that's just the momentum of the rotor and good bearings, which by the way are stainless steel bearings. Advantage of using stainless steel bearings is you can use them completely dry without any lubricant, and that's so far the best freewheeling bearings I've ever tried. Ceramics could probably be better, but stainless steel dry bearings so far have been working best for me. Okay, well, this is the scope shot across the charging battery, and this bit here is the pulse train from the flyback coming from the coils. They're pulsing at about 22 times per magnet pass, and then this is the input from the generator side, just through the magnets going past the coils. And you can't really see the height of the spikes at all. I mean, I can't even see it. I know you can't see it on the camera, but if I expand the shot out, there we go, and maybe turn off some of these lights, there we go. Now you can see the spike goes right off the top of the screen. I'll turn off this light as well, 1 second. I can't even put it on, that's actually goes right off the top. That's a nice bit of resonance across the battery terminals. Don't know if that actually helps anything, but nice to see. So yeah, it would actually go a lot faster if the generator coils weren't putting such a big load on the rotor. I have a neon bulb just hooked up across the terminals there. I don't know what the top speed of it actually would be, but if I disconnect the charging battery so that there's actually no load on the generator coils, you can see it speeds up pretty fast, and the neon light's very bright, so I'm not going to do this for too long. There we go. I don't even want to know what the top speed on this thing is. So yeah, just keeping you updated. I'll probably make my next video when I've got the other switching method hooked up. So yeah, we'll see you around.